Right, this video is going to focus on factorization. I've got a couple of questions here, and we're just going to try and go ahead and factorize these. Now, this is at the grade 9 level. So, in grade 9, there are four methods of factorization that we use. The first one is called common factor, the second one is dots, the third one is trinomials, and the fourth one is called grouping. So while it's not necessarily always in that order, but those are the four methods we use. Now, just to recap, dots usually means we have two terms that are both perfect squares and there's a minus between them. Trinomial means three terms where there's a squared term at the beginning, there's just a variable, and then there's something called a constant. Grouping generally has four terms, all right, and common factor can be any number of terms. Now, that's just a recap, just so that when we're factorizing, you realize that we aren't told how to factorize, we're just told to factorize. So we need to know the four methods and their characteristics before we attempt this. So let's begin with the first one. The first one is 7x plus 14. All right, so if we look at our characteristics, it doesn't fit trinomials and groupings. There are two terms, but this is supposed to be a minus. We have a plus in the middle, so it's not dots. Common factor means that there should be a common factor either between the numbers and or the variables. So in this case, 7x and 14. The number 7 and the number 14 have a highest common factor of 7. 7 fits into 7x and into 14. So we factorize this by writing the highest common factor and then going ahead and opening a bracket. We'll then take our first term, 7x, and we're going to divide it by the highest common factor of 7. 7 divided by 7 cancels, it's 1, and you're left with x. So x fits in here. Then we're going to take our second term, which is positive 14, and divide it by our highest common factor again. And positive divided by positive is positive. 14 divided by 7 is 2. So here we have x plus 2. This has been factorized. Alright, so that's a common factor. For method number 2, well, we have four terms. Now, when we have our four terms, the thing we try to do is in our four terms, we select two groups, and in those groups, we're going to look for common factors. So if I look at the first term and the second term, do they have a common factor? Well, yes, a is common in both those terms. So I can group these two together and go ahead and group these two together. So let's put an equals to on our next line. Now, in our first group, we said the common factor is going to be the variable a. So let's open up a, open out our brackets, and now see what goes into that bracket. So because a is common, or a is our highest common factor, we're going to take this first term ax divided by a. And a divided by a cancels. All we're left with is x. So we're going to have an x in the bracket. We're then going to take our second term of minus 3a divided by our common factor again. Again, we see the a's will cancel and we'll be left with minus 3. So we have a into x minus 3. For our next one, we're going to look for our common factor. So this expression, minus bx plus 3b, has a common factor of b. So I'm going to pull out a common factor of a b. Now, when I pull out this common factor and there's a bracket before it, I can't leave the space empty. There should be a sign that goes there. If I choose to pull out a normal b, that means there should be a plus there. Or in this case, since our b is negative, I could pull out a negative b. But either way, there should be some sign over here. But for this example, let's pull it out as a normal b and see what happens. All right. They're going to say divide our first term. So our first term there is negative bx divided by b. Negative divided by positive is negative. b cancels and you're left with x. So we're going to put an x over there. Then the next term is plus 3b. We're going to divide this by our highest common factor of those two terms, which is b. And b is going to cancel again, which leaves us with a plus 3. So now we've got, it was negative x plus 3. So now we've got this expression here. Now, because we're trying grouping, usually after we are done with this step, these two brackets should be identical. But there's a bit of a problem now. It's that they're not identical. We have an x minus 3 and a minus x plus 3. Basically, the signs on both those terms are incorrect. There is something we can do to remedy that situation. The way we do that is when you pull out a negative sign from any bracket, every term in that bracket, the sign will change. So let's put an equal to sign. I'm gonna bring the a x minus 3 down as normal. Now in my second bracket, I'm gonna factor out a negative sign. So now I'm gonna change this to a negative b and change all the signs inside that bracket. So that becomes x minus 3. Now that I've done that, I see my brackets are identical. I'm going to then write that identical bracket. I'm basically pulling it out as a common factor. And after writing it, I realized that this and this was missing. So those two are going to be written together in another bracket. And that has now been factorized using our grouping method. Alright, so just to recap, our first method we said is common factor, and our second one was grouping. I would like you to make a habit of every time you identify a expression that you want to factorize, write down the method before you start. That just gives you a bit of a direction and an idea on what to do. For our third one, we now notice that we've got three terms. There's an a squared, an a, and a constant. Obviously, the order looks a bit different, but it is a trinomial. So we're going to try a trinomial, but we try to first make sure it's in the correct order. So we're going to put our highest exponent first, which is a squared. Then our variable, which is negative 18a. And lastly, our constant. Now we'll begin factorizing. How do we factorize? We take our constant term and we break it down in terms of its factor pairs. So one factor pair of 81 is 1 times 81. Another one could be 9 and 9. There could be more, but we're going to stop there for now. The trick is, when we find those factor pairs, we're going to now look to get our b value, or the coefficient of our variable, by adding the numbers in a factor pair. So suppose I chose this factor pair. I want to add 1 and 81 in a way that gives me negative 18. Now, no matter how you think about it, whether you do 1 plus 81, or 1 minus 81, or 81 plus 1, or 81 minus 1, you can't get negative 18. So this is out of the question. So let's try it with our 9s. Can 9 and 9 give me a negative 18? Well, yes. Minus 9 minus 9 is equal to negative 18. Now, that's fine. So our factor pair of 9 and 9 can give us the negative 18 if both those 9s are negative. What about if you multiply them? If you take minus 9 times minus 9, what does that equal to? That equals to positive 81, which is also our constant term. So this is the correct factor pair. We then go back to our equation and we open out two brackets. Both the brackets will get a copy of whatever the variable is. So a and a, not the squared version, just the standard version. So just an a, just an a. And then we go ahead and write down whatever our factor pair was. So negative 9 and negative 9. Negative 9 and negative 9. More often than not, you would get that these two numbers are different. So you could have had something like minus 3 plus 4 or whatever the case is. It just so happens that in this case, it's a minus 9 and a minus 9. By the way, a minus 9 and a minus 9 are identical brackets. I can compress this as a minus 9 squared. That means there's two of these a minus 9 brackets, which is the correct answer. Alright, let's move on. For our next one, we see that we have two terms and there's a minus sign between these two terms. So that is going to lean towards a method of dots, difference of two squares. To do dots, we simply equals, open two identical brackets and put a plus and a minus in those brackets. We'll then take our first term, which is 4n squared, and we're going to try to square root that. The square root of 4 is 2, and the square of n squared is n. This is going to go into both my brackets in the first position. Then going to square the number or the second term. We don't need the sign at this point, so negative the square root of 4. The square root of 4 is 2. And this is going to go into the second position of both those brackets. And that's done. So dots is done. Number 5. Two terms, not a minus. The other methods are not going to work, so it has to be common factor. Let's look at these now. So can you think of a highest common factor between 4 and 3? Well, no, there isn't one. But we realize that, well, we know that a squared is a times a, all right? So basically, there's two a's in this one, and there's one a over here. So can I not say that a is common in both these terms? So in that case, my highest common factor is the variable a. So let's pull out a, and then take our first term, 4a squared divided by a. Well, 4 divided by 1 is 4, and a squared divided by a, using laws of exponents, we subtract the exponents. So 2 minus 1, so we're left with a to the power 1. So it's 4a. Then positive 3a divided by a. So 3 divided by 1 is 3. a's cancel, and that's what you're left with. Well, it's a positive 3, so plus 3, and that's going to be factorized. We won't be able to factorize this further. All right, let's check out number 6. So with number 6, two terms, plus sign in the middle. This is leaning again towards common factor, between 4 and 32. So because we're checking highest common factor, there are different methods that you do use if you are generally stuck. But what you can do is either the ladder method, or you can even use just writing out the factors of these two numbers. But anyway, what happens here is that 4 is actually a factor of 32. So 4 is the highest common factor in this example. So I'm going to pull out the 4 and then take my first term, 4x squared divided by 4. Cancel the 4's, I'm left with x squared. So this is x squared. Then I can take my second term, which is positive 32 divided by 4. Positive divided by positive is a positive, and 32 divided by 4 is going to be 8. So my answer here is going to be plus 8. So it's 4 into x squared plus 8. For the seventh one, 3 terms, an x squared, an x, and a constant, dead giveaway towards something called a trinomial. We can begin. Negative 77. Let's go ahead and try to write the factor pairs of this. Obviously, we're going to get our first factor pair of 1 and 77. We can also then get 7 times 11, because 7 times 11 gives you 77. And I'm just going to stop there because I feel like we already have the correct factor pair. So what we can do here now is find this middle term. So 1 and 77 is ridiculous. I'm not going to get a 4 from those. But with 11 and 7, those are four numbers apart. So can I get a negative 4? Well, probably. I just need a negative value. So my 11 should be negative and my 7 should be positive. plus 7 minus 11 will give me a negative 4. And what about if I multiply them? What's positive 7 times negative 11? Well, that's negative 77. So this gives me the constant and the b value. So let's go back. Equals two brackets. Just write our variable in both. And these two factors are gonna go in over there. All right, number 8. Okay, so this is not standard. There's no 4 terms, there's no 3 terms, there's no standard one to this one. But I do realize that these brackets are almost identical. Well, they both have a 4 and they both have an x, but the signs are wrong. But we did something about the signs. So x squared, x plus 4. Now we did something about the signs. What if I pull out a negative sign from here? What if I pull out the negative and I make this a minus 9? Then won't the signs within the brackets need to change? So the negative 4 will become a positive and the negative x will become a positive. Now if I look at these two brackets over here, x plus 4 and 4 plus x, are they the same thing? Well, what's 2 plus 3? 2 plus 3 is 5. And 3 plus 2? Well, that's also 5. So clearly the order doesn't matter when you're adding. So x plus 4 and 4 plus x is the same thing. So we have two identical brackets. We just pull out one of those brackets and then we see what's left. So after you pull that out, you realize x squared, let's use a different color here, x squared and negative 9 are left. So x squared minus 9. Right, now that's done. But are we done? Is this completely factorized? No. This is two terms that are perfect squares and have a negative sign between them. So this is dots. Well, this was grouping, but the common bracket part, I just need to write that down. Common bracket means two identical brackets. So anyway, dots. So let's see what happens. So x plus 4 stays as normal. I'm now going to focus on this term that I said I can do dots for, on this expression. So let's open up two identical brackets. So dots means a plus and a minus in both those brackets. Let's square root the first term. The square root of x squared is, well, it's x. So I'm going to put an x and an x over here. And then I'm going to square root that. Well, just the 9, actually, not the negative. So square root of 9 is equal to 3. So 3. So my final answer is x plus 4, x plus 3, and x minus 3. That has been completely factorized. There's nothing you can do further than that. Now, number 9, 3 terms, x squared, x, and a constant. So clearly that's going to be trinomial, but our coefficient is negative, so we don't do that. We don't work with those. We prefer to have a positive x squared at the front. If you haven't noticed that, that's what we've always been doing, so we're gonna get that again. And how do we go ahead and get that? Well, we factor out a negative sign, which you've seen before. Now when you take out a negative from an expression, what happens to the expression? So the expression, all terms in the expression, their signs change. So a negative x squared becomes a positive x squared. A positive 5x becomes a negative 5x. And a negative 6 becomes a positive 6. We're now going to factorize this expression inside the bracket. Begin by taking our constants and finding the factor pairs. Take the factor pairs and try to find that middle term b. Alright, I believe we can get it from negative 2 and negative 3. Test, if I multiply these two, will they give me my constant? So negative 2 times negative 3 is positive 6. So it gives me that and it gives me that. That has to be my factor pair. write an equals to sign. The minus sign now belongs to the answer because it's been written down. It's not going to disappear, so we've got to carry it forward. Open out our two brackets, write down that variable, whatever it is, and then go ahead and insert whatever our factor pair that works is. Sorry, it seems we've made a bit of an error here. Our constant is supposed to be no, it's right. Sorry about that. So we're looking at this one here. So we've got our positive 6 and we've got our negative 5. There we go. Yeah, all right, that's perfect. Okay, we can leave our answer like that, although sometimes we prefer to distribute this into one of those brackets, not both, but one of them. If you would like, we can just go ahead and do that. Let's just do that quickly. So if you distribute a negative sign into this bracket, negative times x is negative x, negative times negative 2 is plus 2. The other bracket remains the same, and that's our expression, our original expression factorized. Number 10. All right, so we just got a few more. I think till 16. So let's have a look at this one. Two terms, not a minus, common factor. Well, both terms don't even have variables. Only this one has a variable. So clearly our factor is between the numbers. We can then go ahead and say 3 is a factor of 12. So our highest common factor can equal to 3. But because the coefficient of x is negative, let's just take it out as a negative 3. So equals to negative 3 opens brackets. Now let's start with our first term. Negative 3x divided by the highest common factor of negative 3. Negative divided by negative is positive. 3 divided by 3 is 1, and we're left with x. There we go. 12. So let's say plus 12 divided by negative 3. Positive divided by negative is negative. 12 divided by 3 is 4. X minus 4. That's our answer for number 10. Right. Have a look over here. So for this one, two terms, both are perfect squares. Remember, one is a perfect square and there's a minus between them. So we're going to go ahead and put dots. That means I'm going to open out two brackets, put a plus, put a minus, square root the first term. So square root of 4 is 2 and square root of m squared is m. So 2m, 2m. Let's look at our second term. So the square root of 1. Well, the square root of 1 is 1. So that goes over there. Alright, so our final answer is 2m plus 1 and 2m minus 1. Let's see the next one. Two terms, both perfect squares, minus in the middle, dots. Alright, equals brackets plus minus square root. The first term, the square root of x squared is x. So put an x, put an x. Square root of the second term, the square root of 4 is 2. So put a 2, put a 2. Done. Next one. Again, two terms, both perfect squares, minus in the middle, dots, equals brackets, brackets, plus, minus. Right. Square root of our first term, square root of 4k squared is equal to 2k. So let's put a 2k here and a 2k there. Square root of 16 is equal to 4. So let's put a 4 there and a 4 there. Right. Next one. Three terms, k squared, k constant. Trinomial. Begin. Take our positive 27. Factor pairs of it. 27, 3 and 9. Alright. And then we're going to try and look for minus 12. So this is not going to work. Maybe 3 and 9 can give us a minus 12. So minus 3 minus 9 can give us a minus 12. And if you choose to multiply, it gives you a positive 27. So brackets, 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 brackets. Bring your variable down, whatever the variable is. And write your factor pairs in. So minus 3, minus 9. Right. last two. We're gonna begin with number 15. So this one has 4 terms, so we're gonna go ahead and try grouping. All right, so let's have a look. Group our first set of terms. If you group your first set of terms and you pull out a common factor, well, that's gonna give you a common factor of x squared. Open brackets, x cubed divided by x squared is x. Negative 3x squared divided by x squared is negative 3. In my second group over here, I can see a common factor of, well, 9. But let's pull out a negative because our x here is a positive value and our x here is a negative value. So eventually we're gonna want it to be a positive as well. So let's do that in the same step. So minus 9 brackets. Minus 9x divided by minus 9 is x. Positive 27 divided by minus 9 is, well, minus 3. These two are identical, equals. Let's take out the x minus 3 and we're left with x squared minus 9. I'm sure you've seen it. X squared minus 9 is dots. So equals x minus 3. Now when you factorize that with dots, you're going to get x minus 3 and x plus 3. For our last one, we got y squared minus 6y minus 27. So this is a trinomial. We can begin. Take negative 27, 1, 27, 3, and 9. Now we're trying to get a negative 6. So I see it coming from 9 and 3. So positive 3 minus 9 is going to give you minus 6. And if you multiply it, negative 27. So equals brackets, 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 brackets. Bring down whatever the variable is as a standard. And then go ahead and input our factor pair. So plus 3 and minus 9. That has been factorized.